Okay, let's spend a few minutes now talking about the flip side. Let's talk about various ways that we can stage attacks on information assets. So, let me pop this into presentation mode here so it's a little larger there for you. Okay. So, we've already gone through the definition of an attack, and so we've got an idea here, but really there are lots of different ways that you can classify these attacks. And so we'll just go through some of these briefly. Some of this we've already touched on in previous conversations, so it won't be too much to add to some of it. Malicious code, malware, what have you, is dropped for any number of different reasons, not just as the slide here states, to destroy or steal information. Malware is now being used to add computers to botnets. And so when we start thinking about malware, yes, it does these other things, and these are all different vectors through which malware can get dropped. But the end goal here is again depends on what the attacker has in mind and what the code was written for. So yes, it could frag a system completely, could destroy partially. Data could be that the purpose of the malware in question is to do nothing more than to add that system to a bot herder's collection of compromised systems to use for some other purpose down the road. Multi-vector worm, not really much in play anymore, so I'm not going to talk too much about it. So compromising passwords been in the news a lot lately over the last little while. Right, there are those who argue that user credentials, username, password, what have you, is an antiquated method of authenticating users to systems and is doomed to failure. There are some who make that argument. There are others who say, okay, fine, show me something better, and then things get very silent. And so when we talk about compromised passwords, they can happen for any number of reasons: social engineering, exposed left open workstations, what have you. Also, they can happen as a result of improper storage by the application or system in question of those passwords. Or improper transmission of credentials over a network, including passwords, to authenticate against the system in question. So we can compromise passwords and user credentials in a broader sense any number of ways. There have actually been web-based applications that have been compromised where it was discovered that credentials were stored in plain text. They were not hashed in any way, shape, or form, no protection at all. Just plain text entered into a table in a database. So we can try and brute force. We can try dictionary attacks. We can try attacks using rainbow tables. And with rainbow tables, we see those used when a set of hashed credentials have been grabbed from a system in question. And so remember, hashes are one way in nature. You cannot reverse a hash and get back to the unhashed plain text password. But when we've got a list of known passwords, we can hash them in the various hashing algorithms, and then just compare the results. And when I find the hash string that I've captured matches a hash string in my table of computed hashed passwords, I can then just back it right across to the plain text entry, and we're good to go. Might attack a system through, you're not really going to see a DOS attack anymore. What you're seeing now are distributed denial of services, or DDoS attacks, and that ties back into dropping malware on a client system earlier, where could be the purpose of the malware from the attacker is to have that compromised system now participate in flooding a pipe, for example. When we talk about a distributed denial of service, we're coming in from all over the place. Okay, and something to think about here now with the increased reliance on cloud computing. One of the things that makes cloud computing so popular is that you can spin up new assets on the fly or close to on the fly from cloud providers. So we'll use an Amazon computing instance as an example here. So let's say that I've got a web-based application or set of assets that I want to put up in the cloud, and Amazon's elastic computing environment seems to work for me. And so I stand up a web server there, and I purchase a decent amount of bandwidth to use. We're starting to see increased. One of the ways that attackers can take an organization offline is not just through engaging in a DDoS attack in and of itself, but the consequences of a DDoS attack. The natural reaction of cloud computing environments is that when we start seeing, unless limits are put into place by the customer on the cloud computing source, remember that with cloud computing you pay by the unit, and so if we're talking about memory, you're paying by the gig. If we're talking about clock CPU, we're talking about paying by the number of processors that you've requested for your virtual instance there, and how fast it is. When we start talking about drive capacity, we start talking about purchasing in terms of units of gigabytes, and with bandwidth, we purchase in increments. And so one of the things that especially with a lot of businesses now finding that they can stand up their own infrastructure for their applications in a cloud-based environment pretty quickly. I may DDoS an attacker may DDoS a box, not for the sole purpose of taking the box down from a technical perspective, but maybe driving the cost of operation so high for the organization that's paying the bill for that cloud-based instance, that you can now cost an organization tens or hundreds of thousands of dollars a day just by DDoSing their box. You may not take the box down, may not ever go offline, but you make the cost of doing business so expensive that it may take somebody out of business. The concept of IP address spoofing is nothing more than replacing the legitimate source IP address in the packet that you're sending with that of a bogus IP address, so that in theory activity cannot be tracked to you. You cannot spoof IP addresses if you're looking to establish a TCP session, however, and keep that in mind. If I'm just looking to engage in DDoS type behavior, then yeah, I'll spoof IP packets all day long and change the source IP address to something that doesn't point the finger at me. But if I need to actually open up a session with that box for reasons of further compromise, then especially TCP based, or anything where I need to get data back from the system in question, I cannot spoof the IP address because I need to get that traffic back to me to do whatever it is I need to do with it while staging the attack. Man in the middle, the idea that, and this happens primarily with wireless networks, where you may see attackers set up an access point that is rogue in nature, where you think you're attaching to the Starbucks network, but in actuality you're attaching to the attacker's wireless access point, and they were able to sniff traffic as they need to and read traffic on the fly. One of the big ways to defeat man in the middle is end-to-end encryption. And so what that means is traffic is encrypted before it leaves your system. So in that situation, it doesn't matter if you have been subject to a man-in-the-middle attack, because traffic is encrypted before it leaves your system. It cannot be read by the attacker once it hits the malicious network. In situations, however, where you're trying to authenticate to web servers, for example, it is possible for a man-in-the-middle to spoof what appears to be a secure connection, and is able to then grab your credentials, pass them on up the chain to the legitimate site that you're trying to authenticate to, and then bring everything back. And because the encrypted session is actually created from you to the malicious access point, and then a separate session from the access point to the legitimate site that you're trying to visit, the man-in-the-middle can encode and decode traffic on both ends and be good to go in terms of grabbing whatever the attacker needs from your traffic like that. Email attacks, really the only thing to consider here. Spam's an annoyance. Basically, at the end of the day, if you click on a link in an email, you're asking for trouble. Even if you think the email may be legitimate in nature. Let's say, for example, you get an email from your bank and it looks legit, smells legit, feels legit. Don't click the link. If it's an actual legitimate request from somebody you do business with or somebody you have an account with, take the extra 5 seconds, go ahead and open your own web browser, and then type in the URL of the site that you know you need to go to yourself. Don't click on the link, and you're in better shape. Packet sniffing. The beauty of packet sniffers is that they are transparent in nature. With rare instances, they don't interfere at all with network traffic at all. Basically, it's just a device on the network that is grabbing everything as it flows by. Because there's no real interference with network traffic, they're almost impossible to pick up. So those are fun to run, and sniffers can either be good or bad depending on the authorization or lack of by the individual who put the sniffer into place. It's not uncommon to have legitimate packet sniffers set up on the network for business monitoring purposes. Not a problem, but they can also be malicious when an attacker puts them into place. SE, social engineering. We've talked about this previously. The humans are the weak link in the system most times, and so if I'm able to convince you to do something that I need you to do that you otherwise would not do, and it allows me to gain access into that network environment or that system in question, then I'm good to go. Buffer overflows. It still boggles my mind that even after 30 years or so of talking about this, we still have issues with this. A buffer, remember, is a location in memory that is a finite size. And so what happens when you send so much input in through a field in an application that it actually physically overflows the size of the buffer, so that the application and the OS then don't know what to do with it. When in situations like this, the net result is that most times you create an instability in the system that leads to the application in question that you use to create the overflow crashing, and you would end up getting to either getting to a command line of some type or getting some type of access to the system other than what you were really authorized to do. And so then you go from there in terms of taking advantage of that weakness, and now you've gotten maybe a foothold in a system, or maybe you're able to use a buffer overflow in such a way that you are able to monitor other portions of the system that you're on, or the application that you're running it against. So I think that's about all. Yep, that's about all that I've got for this portion of our conversation. Thank you very much for your time.